back, students. We're on question 11. Let's get straight into it. A rectangular building site. So it's in the shape of a rectangle with one side fronting the road. There's an interesting word. Is to be fenced off. Okay, so the building site is to be fenced off. The side fronting the road which does not require fencing is 1 meter long, L meters long. Okay, very good. Wonder why it wouldn't. You would expect it needs fencing more than anything, but anyway. We'll go with what we're being told. The sides perpendicular to the road, that is this one and this one, are X meters long. Okay, so let's make it very, very clear that we understand that the opposite sides in a rectangle are of equal length. So we'll explicitly define this as being X meters long, this line segment here. The sides, yeah, we're done. I should have probably marked that off that I'd read it. The length of fencing that will be used to enclose the 3 sides is 160. Okay, again, let's say that we do understand that this is LM and that this 160 meters is collectively these 3 grouped together. Write an expression for L in terms of X. Well, first let's write an equation that these 3 values, X and X, which we can write as 2X plus L equals 160. Okay, and now what we're going to do is we're going to make L the subject. In other words, we're going to isolate L. Okay, so L is a term on the left hand side, but it's not the only term. The 2x is a term we don't want here, so we will transpose it, take it across. So it will turn into negative 2x. So L is equal to 160 minus 2x. And that's us done. A little box here to say you're finished. Okay. Now we will show that the area of the site in meters squared is negative 2x squared plus 160. Okay, let's do that by first of all understanding that the area of a rectangle is equal to length by width, or in our case it's equal to X by L, but we can replace L in terms of X, so we can have X times 160 minus 2x, which is equal to 160x minus 2x squared, which is what we were asked to do. Now don't worry about constantly battling with the commutativity of terms, okay? It doesn't matter which one comes first, and you don't have to worry about it. You don't have to state anything or do anything. Just leave it. Okay, draw a graph of the function in the domain. Okay, great. We're going to use a calculator here to sub in our expression from down here. I barely showed you there. Okay, which is minus 2x squared plus 160x. So let's get the calculator up. Let's push it over to the side. A little bit to the side, we don't want it too far to the side, so we can stay in touch with our maths here. And let's turn it into table mode, option 3. I'm wondering, am I going to pause the video and bring up the second calculator? I am. Okay, I think that worked out for me nicely. I've unpaused and we're driving on. So we're trying to fill this in now, just to check the domain. We're in a domain from 0 to 90 for the x value. Okay, so I just go back here. I picked option 3, and here we're taking the table option, and we have no button we can push here, I don't think. I'm just going to try, but I don't think it'll work. Push 3, no. So I'm going to have to use the toggle button here to open up table in this calculator. Okay, now I have fx and g of x turned on. Let's just leave them there for now, that's fine. and here we'll take option 3, and I'm filling in f of x. So if you we'll just refer up here, it's already told us here that we want to be filling in minus 2x squared plus 160x. So that will be here in the f version. Is that going to fall off? No. Okay, so minus 2x, now the x is the red x here, x squared plus 160x. Don't forget your alpha. Okay, now we say equals, we don't really need a g of x. We won't start at 1, we'll start at 0. And I'll say equals, do you want to end at 5? No, I don't. I want to end at 80. Do you want every single value? No, we want to step in steps of 10. Okay, and we let it rip, calculate them all in one go. We'll key those values in here. Now, I'm not going to use pen, I'm going to use pencil because we're graphing. Okay, and so mistakes are quite likely to happen. We want to be able to deal with them. So 0 gives us 0, 10 gives us 1400, which is a little bit less than 1500. 20 gives us 2400, which is a little bit less there, just eyeball it. 30, just a nice tool to have here is this as well. 30, because you can use it as a pointer as well. 30 gives us 3000, that's there. Now I'll have to go back to my calculator and toggle down. 40 gives us 3200. Notice how we're leveling off here. $50 gives us back down to 3000. $2,400. And now this thing happens, that's because of the symmetry and because of the axis of symmetry, we can start using our set square to come straight across to the relative positions. Okay. Now I'll show you in a minute what to do in the other calculator. I'm just kind of preparing myself for the mental anguish I'm going to be put through probably, but we get there. I'll try to keep calm as we battle with the new calculator. You know what, and I don't want to, we might be pleasantly surprised, and we do need to be prepared to learn new stuff. So in terms of, there are various ways of dealing with this. I could manually fill in the domain down along. It's a bit silly because there's a better way of doing it, and then I come along. But so I'm not loving that. We're going to skip that. We also might want to turn off g of x if we can figure it out. But there's going to be learning going on here. Let me get into settings here for a second. No, that's not happening. I don't know where I am now, but let's just go back to home if it'll let me. That's interesting actually. A double click of home, I noticed, brought me home. If you like, brought me to calculate. Anyway, let's go further. We can look at our functions and our variables. Let's click on variables. We have x there. Let's come back off that and let's go into, that's okay, functions, we call it lost again. I'm going to hit home twice just to see that happen. So this is project-based learning. This is very, very important. It's just going to take a little bit longer than what we bargained for, but it's important that this isn't hidden from you, because this is where I'm going to learn about this calculator right now, by project-based learning. In other words, by inquiry-based learning. I know it's either catalog or tools. In catalog I have, let's have a look at that. No, I don't like it. No, I don't like being in catalog at all. Let's go to tools for a second. It won't let me into tools. It won't let me out of catalogs. Let's go home. Boom, boom. functions again. I just taught us tools. Right, this is more looking like it. What's my table range going to be? And there we are. Okay, so I need to make a note for myself to kind of improve my learning here and make sure this isn't just short term and gone up in smoke. What did I do, guys? I hit after table I did tools, and under tools did I get, again, let's go home and see, can we discover it again. So this is learning to learn. It's not when you're learning something and stumbling upon stuff during inquiry-based learning for the first time, you've got to kind of take a slightly different approach, a more systematic approach of note taking. And because this is my permanent red book that I can keep and refer to and make further notes from tomorrow and the day after, this is my my so-called copy, my notes copy, if you like. Okay, so under table again, I'm clicking OK, and I'm going into tools, and I'm table ranging. So tools, table range. And that brings me into the range that this naturally brought me into by default. So what do I want to start with? 10 actually. What do I want, or 0, but I know 0 gives me 0, so I'm okay starting at 10. I probably want to execute that. What do I want to end with? 80. I want to execute that. What's my step? 10. Execute that. It says execute. Now I haven't filled in the function yet. I can give it a go and see what happens, but I got to get all these errors. Back into tools, I'll define my fx. Just a quick one here is, I think I might be able to turn off g of x here. I will. So I'll just turn on f of x on its own there. Okay, now that isn't going to do me much good. Let me see, can I come back into tools? No. Escape. Okay, well, let me back out. If I go home, have I lost everything? No. Let's see. That's tools. Let's see, did it hang on to my range? Yes. Do I go okay? No. 10. With this, we may just fumble through it this time around and then come back again for deeper learning. Okay, execute again. I know my execute isn't going to work very well because I haven't defined my function. I can define it here or here. I'm not sure which I want to do. Let's go into functions. Say f of x. Am I being given a chance to define it? I have no idea, guys. No idea. This calculator can lead to some frustration. Anyway, we definitely like this, and we like the idea to be able to define our f of x's. Well, let's define f of x. Here it is. And now I can go back and look at my function here, which is negative 2x squared. Shift x. And I'm going to use the square function there, so that keeps me down on the off the index or the power line. I'm down at the bottom, and I want to add 160x. Okay, and it has gone ahead and executed all of them, and I'm getting the same values as I did the last time. Just in terms of that, you know, look, they're not giving, well, I will use a vertical table here, so just copy down what I see on my calculator, x, f of x, and we'll go 0, 10, 20, 30, 40, 50, 60, 70, 80. Okay, 0, 1400, etc. Okay, they're all done. I mean, I'm not going to even use them because they're already on the graph. So, but it's just there in case. It's just good practice, as you know, when mistakes happen and so on. And what if our graph isn't right and this ends up giving us partial credit? Use your graph to estimate the maximum. I'm using the mouse here. Let me use my pen. use your graph to estimate the maximum possible area of the site. Now we need some careful higher order thinking here. This is the area. When does the graph become maximum? When does it become highest? It's here. And I'm using my graph even though what the exact value is in my table, so it's not really using my graph, technically speaking. But that's the kind of criticism I spoke about that we might have in edcob papers, in that they're not state exam papers, and the exact wording might leave a tiny bit to be desired from time to time. So, you know, a graph, because of symmetry, will often have not a maximum at all. It'll have two, you know, almost maximums, but in between them there is a maximum, and that would have been a better time to use this wording, because we already know from our values that 3200, and from the concept of symmetry, look, there's my axis of symmetry here, where you have axial symmetry in the line, x equals 40. This is the exact middle. Anyway, so to make a long story short, the answer is 3200. I have to be careful about units, but it seems to be meters squared is the area. So if they go with this is that this thing can be continually, according to this, they can only use, they're using 160 for the three-sided perimeter, and the maximum perimeter they'll get will be this. The maximum area they'll get based on that perimeter is this 3200 meters squared. And I'm sure the next question comes. Yeah, well, there's a few more questions coming up. And the disappointing one is that they didn't ask what does this convert into as in x value, which would have been a bit of algebra solving as a quadratic equation. Use algebra to find two values of x, which will give an area of 2000. So we're coming across at 2000. There's no values there as such, so we're using the graph to interpolate, because it's reading off a value between other values. Extrapolate would be to go further outside. So we're going to interpolate these values by using the idea that we're coming in here and down here. Now I think maybe the transparent 30, 60, 90 might be a little bit more satisfactory here in the video. I might try and turn on the lights now and that for the next video too, because I'm using natural daylight, which might not be a great quality. Then again, it can be nicer. But I'm in the inside of the room and there's quite a bit of shadow. You see the shadow in there? And maybe it's not too bad. Okay, and we need to read off these two values. Use here to find the values of x. So the first value of x there is below 15 if I'm eyeballing it. I'm going to call it 14 meters, or the second value is below 65, I call it 64 meters. They'll always give you a range for that, so don't you worry too much about that. Okay guys, that's it. And just the extra little bit, the bonus bit, would be what if they had asked us to turn this into an x value? Well, the answer will be 40, but let's see how the maths would have worked out there. We would have got negative 2x squared plus 160x should be equal to 3,200. So I'm just going to solve this. We know the answer is going to be 40, but it'll be a bit of fun. Okay, so first of all, I don't like the negative lead, so I'm going to turn it into a positive lead, and I'm also going to half. So x squared minus 80x equals negative 1600, and so bringing him back, he becomes positive 1600. X squared negative 80x positive 1600. Now, you could use the completing the square, or you could spot that 40 by 40 is 80, which I have spotted. So x minus 40, and you could use the minus b formula as well, of course, but it'd be a bit excessive. So x minus 40 squared is this, equals 0, so x equals 40. And that's an example. Sorry, I need to. That is an example of a single solution or a double root. Okay, that's it guys. As always, I will see you in the next one.